Good day, students. On this clip, we're going to be going over some examples on how to find the positive and negative coterminal angles of given angles, okay? We're going to graph the angles, the given angles in standard position, and then we will go ahead and find a positive and a negative coterminal angle. All right, so before we start, let's take a look at what the definition of coterminal angles are. So what does the word coterminal mean? Okay, uh, coterminal. What does that mean? Well, we know that an angle has a terminal side. So let's say we wanted to graph angle theta, for example. Uh, and then we have a coordinate system like this. So if we wanted to graph theta, uh, it's gonna have to end up somewhere. Okay, so let's say theta is somewhere in quadrant 1. All right. So what does the graph I just sketched mean? Well, it means that this ray right here represents the terminal side of angle theta. Okay, so this is a terminal. This is known as the terminal side. Terminal side. Okay, so if this is the terminal side, let me write it properly. If this is the terminal side, what does coterminal mean? Well, we're going to determine the meaning of coterminal by using this whole idea of terminal side, all right? So co, as the word suggests, means the same or common, like same or common, okay? So if two angles have the same or common terminal side, they are coterminal angles. So if this is an angle, and another angle when you're graphing it happens to fall right over this angle right here, it is said to be a coterminal angle. Okay, so how can we how relative to this angle, how can we get another angle to have the same terminal side to this? All you just simply do is just rotate full circle, right? I can either go counterclockwise, I can go clockwise or counterclockwise. Okay, so where direction does the clock go? It goes this way. So if I go clockwise, going down is going to be a negative direction. And if I go counterclockwise, which is up, it's going to be a positive direction, okay? So if I go down and I rotate starting from this angle and I go full circle and end up here, that is a negative coterminal angle. And to do that, all I just need to do is I need to just subtract 360 degrees or subtract 2 pi, okay? If the problem is in radians, we use 2 pi. If it is in degree, we use 360. I mean, if it's in degree, use 360, yes. And if I wanted to do the positive coterminal angle, what do I do? To do the positive coterminal angle, I start from here, and I go full circle and end up right back here, okay? To accomplish that, all I just have to do is add 360 degrees to theta, or I subtract or add 2 pi to theta, okay? So this angle right here, this terminal angle right here, can be represented using the following. This angle that we have is theta. It is also theta plus 360. This is a positive coterminal. Or it could also be theta minus 360 for the negative coterminal. Okay? And it can use plus 2 pi or minus 2 pi. So that's the whole idea behind coterminal angles. It's all about rotating full circle, either counterclockwise for positive or clockwise for negative. Okay? Alright, with that in mind, let's take a look at some examples. So it says find the positive and negative coterminal angles for each given angle. I'm going to do the graph first so that we have a good idea as to what we're dealing with. Alright, so let's go ahead and do the graph. Alright, so I want to graph 198 degrees, so let's go ahead and label our angles. So the positive x coordinate is your starting point. This is 0 degrees. Since it's a positive angle, positive means we're going to be rotating counterclockwise, right? Remember, counterclockwise rotation is positive, and clockwise rotation going down is negative. Okay, so we're going to be going up. One of our circle is 90 degrees, and then half a circle is 180, and then a third of a circle is 270. We can stop here because 198 is going to be somewhere in quadrant 3, okay? So the terminal side for 198 is going to be somewhere here. So there is 198 degrees right here, okay? 198 degrees. All right. So uh, what's the first positive coterminal angle? To do the positive coterminal angle, all we just do is we're going to start from here, and we're going to rotate counterclockwise full circle. So rotating like this, counterclockwise full circle up to here, means we're just going to add 360 to get the positive coterminal angle. Okay, so let's do that. So positive coterminal angle, positive coterminal angle is going to be 198 plus 360. If we add it up, we're going to get 8, 9 plus 6, 15, 5 carry 1. So we had 8, and then 9 plus 6 carry 1, and then 2 plus 3 is 5, so 558 degrees. So the first positive coterminal angle is going to be 558 degrees. All right? And to get the negative coterminal angle, we're going to start from here, and we're going to go counterclockwise. Remember, counterclockwise is negative. All right? So we're going to go in this direction, around like this, to there. That is minusing or subtracting 360 degrees to get the positive, or to get the negative coterminal angle. Okay, so negative coterminal angle is going to be 198 minus 360 degrees. Okay, so let's go ahead and do the subtraction. I'm going to do 10 minus 2. I mean 10 minus 8 is 2. And I have 5 here. 15 minus 9 is 6. And we have 2 there, 1. So negative 162 degrees, okay? If you're subtracting, you just put this under and then subtract it. I did it backwards, so that's why you get negative 162. All right, so your negative coterminal angle is going to be negative 162 degrees. Okay, so the answer for option 1 is letter A. Okay, all right, let's go ahead and try number 2. For number 2, we actually have a negative angle here that we're looking at. So let's figure out what the terminal side is, and then we'll find the negative and positive coterminal angles for that one. All right, so negative 135. This is 0 degrees. Remember, if you want to go in negative, you have to go downwards or clockwise. And if you're looking for a positive angular measure, you go upwards or counterclockwise. Okay, so we're doing negative 135, so we're going to go down negative 90. Keep on going, negative 180. Oh, we passed it. So 135, negative 135 is going to be somewhere here in quadrant 3. Okay, so this angular measure right here, this is negative 135. Okay, all right, so now let's find a positive coterminal angle. To find a positive coterminal angle, what we'll do is we'll start from here and we'll rotate counterclockwise full circle to end right here, and that means we need to add 360 degrees. Okay, all right, so positive, this is one of them. Okay, positive coterminal angle is going to be negative 135 plus 360. Okay, so to work this out, I'm just going to put 360 on the top, subtract 135, 10, 5, 5, 2, 225 degrees. So the positive coterminal angle for this is 225 degrees. That's when you rotate in that direction. Okay, all right, so how about the negative coterminal angle? To find the negative coterminal angle, you just do the opposite, right? So instead of going counterclockwise, you go clockwise. Starting from here, you're going to go clockwise, which is up and around like this. Full circle right here. That is equivalent to subtracting 360 degrees from the original angle, okay? So for the negative coterminal angle, you just do negative 135 minus 360. So the signs are the same. You can just add them up and keep the sign, right? So it's going to be negative 5, 3, 9, 1, 3, 4. Negative 495 degrees. So the negative coterminal angle is negative 495 degrees. Okay? So the answer to this is option D. Option D. Alright, now let's try another example. This one involves radian measure, negative 3 pi over 2. So let's go ahead and graph this one first, and then we're going to find the positive and negative coterminal angles. Okay, so we have a coordinate system. This angle is negative, so we're going to start from 0. And remember, negative angles, you go clockwise, right, for negative. And then for positive, you go counterclockwise. It's kind of backwards. The clock's direction is negative. Okay? But starting from 0 goes down. Alright, so this is 0. Instead of using degree for my calibration here, I'm going to be using radian. Okay, so if you do quarter of a circle, it's negative pi over 2. Half of a circle is negative pi. 3/4 of a circle is negative 3 pi over 2. So there goes our terminal side. It overlaps with the positive y-axis. Okay, so our terminal side lies right here. Okay, so let's indicate the angle swept. We started from here and we rotated right around like this to generate negative 3 pi over 2. Alright, so let's find the positive coterminal angle. To do that, we'll start from here, and then we're going to go in a counterclockwise direction, full circle, to here. We know that is equivalent to adding 360, but 360 is the same thing as 2 pi. So what we're going to do here is we're going to add 2 pi. Okay? Alright, let's go ahead and do that. So, positive coterminal angle, terminal angle is going to be negative 3 pi over 2 plus 2 pi. Okay? And if you do the calculation, you're going to get you're going to get positive pi over 2. Okay? Because you can write this as well, let's do it the long way. I can write this as 2 pi over 1, and then find the LCD, times it by 2, top and bottom, times 2 times 2. So that will give us negative 3 pi over 2 plus 4 pi over 2. And then when you subtract, you're going to have pi over 2. Okay? So your positive coterminal angle for this one is pi over 2. Okay, so pi over 2 is coterminal with negative 3 pi over 2. So to do the negative coterminal angle, all we do is we're going to start from negative 3 pi over 2, and we're going to go, I think I made a mistake with the direction of my arrows. The other one I was supposed to go, yeah, that was correct. Sorry about that. That's right. Right, so the negative coterminal, we'll start from here and we'll go clockwise. So we'll start from here and go color. Start from there and then we'll go like this, clockwise, full circle, down. That's my negative coterminal angle, and that's equivalent to subtracting 2 pi from the original angle we started from. Okay, so let's work that out. So negative coterminal angle, negative coterminal angle is going to be negative 3 pi over 2. And we're going to subtract 2 pi from that. Okay, let's find the LCD again. To find the LCD, multiply by 2, top and bottom, because the LCD of 1 and 2 is 2. So that gives us negative 3 pi over 2 subtracted from 4 pi over 2. And then we add the top, negative 7 pi. The denominator stays the same. And there goes my negative coterminal angle. So the negative coterminal angle is negative 7 pi over 2. Okay, so now let's take a look at this. Which option has negative 7 pi over 2 and pi over 2? Option number letter B. Okay, so our answer is B. So thanks so much for paying attention to this presentation. Please subscribe to my videos for more worksheets just like this. and you can share this with your friends via Facebook or Twitter. You can also feel free to request videos in the comment section of this video. More clips can be found on mygoodserve.com. Thanks again and have a wonderful day.